Alright, welcome everybody. Today in this video I'm going to be showing you how to configure MPLS with traffic engineering. I have the basic layout here. I have all the subnets ready. I just need to configure everything. So right now all these devices are blank and we are going to configure it from scratch. So I hope it doesn't take too long, but I'm going to take you from beginning to end. Let's do it. Let's play some music. And let's start with doing the outside routers, R5 to R6, and then we'll configure the service provider routers. So let's go to R5 first. Expand this out. Config T, interface loopback 1, 555. What is that? 45? 45. And what we're going to be doing here is doing OSPF throughout this entire topology. Alright, that should be good. Go to R6. Let's do the same thing. OSPF 1, network. I was like, yep, that's the wrong way. Oh, come on. Let me double check that I did router 5 correctly. Yeah, I did it correctly. Okay, good. Now let's configure router 1 with initial config. Alright, that should be good. Router 2 for at least initial config. Nope. No, exit. No loopback 21. No interface loopback 21. Interface loopback 1. One, now where is the 0? We got 2 neighbors, which, alright, good, yep, that's what I expected. Okay. Router 3. No, didn't want that. Come on. No, not 9. Do show run section router. Okay, good. And I should be getting 1 neighbor. And okay. What is wrong with serial 2? Let me look at router 2 here. I must have configured something wrong. Yep, I did. Okay. It's alright, that's why I check. And OSPF come up. Good. And then now router 4. OSPF 1, network 0, 0, end. Let's write that. How many neighbors? I should actually have 4 neighbors. 1, 2, 3, and 5. 5 should come up. Oh wait, no, I didn't do that side yet. Router 5 should now be able to ping router 6. Or router 6 should be able to ping router 5. Just got a neighbor adjacency, so there you go. Good. Show IP route. All the loopbacks. Yep. Alright, that looks good. Okay. So now I have basic OSPF connectivity throughout this whole entire topology. Now what I need to do is I need to configure R1 through R4 with LDP. And the way I'm going to do that is a cheat method. It's actually not a cheat method, it's a legit method. You just go into router OSPF 1 and then just say MPLS LDP auto config. Now all interfaces that are enabled for OSPF now have LDP, label distribution protocol enabled. Easy peasy. So now let's go to router 2, do the same thing. Router OSPF 1, MPLS, LDP, auto config, good. Router 1, config T. Router OSPF 1, MPLS, LDP, auto config. Should be getting neighbors. I'll leave that up. And he did. Good. Config T router OSPF 1, MPLS, LDP, auto config, and I should be getting 3 neighbors. Good. Now if I do a show MPLS forwarding table, I will see all the tags for all the routes in OSPF. Okay, MPLS, done. Now what we need to do is enable the reservation protocol, RSVP protocol, on all interfaces that are participating in MPLS. So that means on R4, I got to do a certain command in global config and then put it on all these interfaces. Okay? So let's do that. R4. The command is config t MPLS traffic engineering tunnels. You enable that globally, then you go into each physical interface and then enable it. I also, since these are serial links, I want to make a reservation bandwidth for at least 1,000 kilobits per second, right? So pretty much 1 meg. So I'll go into interface S2/2. I will say MPLS traffic engineering tunnels to enable it on the interface. And then I will say IP RSVP bandwidth 1,000, and then do this for each interface. And we will copy that. Right, 2, 1, 3, yep, good. Now let's go to router 1. Exit MPLS traffic engineering tunnels interface S2/2 MPLS traffic engineering tunnels IP RSVP bandwidth 1,000, then go into 3, exit, do right. Okay, router 2 now, do the same thing. MPLS traffic engineering tunnels interface S2/2 IP RSVP bandwidth 1,000. Okay, and right. I'm not done after this. I need to actually make the reservations, like set the configurations for the reservations. This is just enabling RSVP. Config T, MPLS, traffic tunnels, interface S2/3, enable that, IP RSVP bandwidth 1,000. Okay, good. Now that should be it for the RSVP section. If I were to do a show IP RSVP neighbors, nothing has actually been reserving the bandwidth yet. So I haven't made an actual traffic engineering tunnel. That's why I don't have any neighbors. So now I actually need to configure the tunnel reservation, and I will do that on router 4. And what we do here is we say interface tunnel and then give it whatever number you want. Make sure it has IP properties enabled, so you will say IP unnumbered. It really doesn't need to have an IP address. It just needs to reference something so it could actually have IP properties turned on. So you will do the IP unnumbered and then just use the loopback address. That's fine. Now, where is this tunnel going to end? Well, this is going to end at the other PE router, which is router 2, and it'll use the loopback. So I will say 2.2.2.2. The tunnel mode is going to be MPLS traffic engineering, and you just hit enter. Now this is where you will actually be kind of specific with this traffic engineering tunnel. So this next command, which is tunnel MPLS traffic engineering auto route, right? So if I were to do this auto route, it says parameters for IGP routing over the tunnel. So this is you telling OSPF about this traffic engineering tunnel. So it'll use this constraint shortest path first. Okay, so auto route, and then you'll say announce. So you'll announce this. You'll announce this to the IGP that you're using, whether it be OSPF or ISIS. Okay. Then we need to set the actual bandwidth that we want to have for this tunnel. Yes, we did reserve 1,000 kilobits throughout the topology, but this tunnel specifically, we want to have, let's say, half of that, or 512. Okay. Now this is where we kind of get specific with the path that we want to take for traffic engineering, because the whole point of traffic engineering is to make sure it goes a certain path rather than the shortest path. But the shortest path could be the best path. So we are actually going to set that up. So the path option, and this is where you can have multiple paths within the same tunnel. So 1 being the priority, the highest priority, 1,000 being the lowest priority. But we'll just say 1, and then we'll say we'll take the dynamic path. Okay, so if I were to go back, if we looked at dynamic or explicit, it said set up based on dynamically calculated path. This is due to OSPF's shortest path first. Okay, so we'll just say, you know what, take this tunnel for the shortest path. Cool. All right. Now let's create another tunnel, and we'll pretty much do the same thing, except we'll make an explicit path. IP unnumbered, loopback 1, tunnel destination 2.2.2.2. Then we'll say tunnel mode, MPLS traffic engineering, tunnel MPLS traffic engineering auto routes announce. So let's tell OSPF about it. Tunnel MPLS traffic engineering bandwidth again. Let's say we still want the same amount of bandwidth. Now this is where we're going to be explicit, where I want to go through certain routers for this path. This is where you kind of tell it to be specific. So what I will use is actually, let me actually type it in and see if it allows me to. So we'll still do the path options. Option 1, because this is a whole new interface, but instead of being by dynamic, I want it to be explicit. So I want to tell it to go through a specific path. Name MPLS R4 to R2. Okay. I didn't define this yet. This is something I have to define, so I'm glad that it actually allowed me to keep that. So now let's define MPLS R2 to R4 to R2, and it'll start with IP explicit path. Give it a name, and it's this name right here. Now, what path do we want to take for this tunnel? Yes, the shortest path is this route. What happens if I wanted to go to R1 and then to R2? This is where I explain the specific paths here. So what I'll say is next address. What is the next address, the next hop that I want this route to take? And it's going to be router 1. So I'll say 14.14.14.1. Now what's the next address after that? Which is this guy, 12.12.12.2. And then we want it to end at the loopback, so I'll say address 2.2.2.2. Done. Exit. Now that I have the path set up, I need to tell OSPF about these new attributes. So I'll say router OSPF1, I'll say MPLS traffic engineering. I want this to be a part of area 0. And then also I need it to use the router ID of loopback 1. Now, when I do this, my tunnels should come up. I'm hoping, if I did everything correctly, that it should come up. And of course, it didn't come up. Show. Oh, you know why? Because I have to do this for all the other routers. Okay, let me go and do that. Then these tunnels should come up. So let me put this guy up top here so we can get those notifications. So let's go to router 1. Let's do this. Bring this up. Router OSPF 1. MPLS traffic engineering area 0. Router ID loopback 1. Let's do router 3 right now. Router, OSPF 1, MPLS, traffic engineering, area 0. Area ID, nope. Router ID, loopback 1. And then let's go to router 2. Config T, router, OSPF 1, MPLS, traffic engineering, area 0, router ID 1. Now hopefully the tunnel comes up. There you go. Now my 2 tunnels came up. Good. So now I have the explicit path. Let's bring this, let's make this bigger here. Show MPLS traffic engineering. Oh, come on. Ugh. Show MPLS traffic engineering tunnels. Hit enter. Here you'll see our first tunnel, tunnel 0. It's up. It's operationally up. The path is valid. Signaling is connected. You get to see what the bandwidth that we have for this tunnel. And the source is router 4, the destination is router 2. And then the explicit route, it looks like it's going straight to router 2. It's because we have this direct path. Remember, tunnel 0 was that dynamic path. Okay, do I get to see dynamic up here? Yes, type dynamic. Okay. If I hit space, we'll get to see our explicit path for router 1. Oh, I'm sorry. Tunnel 1. So we have R4 tunnel 1. It is up. It is operationally up. Signaling is connected. It is valid. There's the bandwidth that we reserved. And look at this. Look at this RSVP path. My address is 4444 because I'm router 4. But look at that next hop. That next hop is 14.14.14.1. Then we're going to go to 12.12.12.2. And then the loopback right there. So this explicit path is going to be going from R4 to R1 to R2, and then the loopback of R2, right? So now if I were to do a show IP route to, we'll just say look at OSPF. From router 4's perspective, to get to router 6 here, what is his path to get to router 6? It looks like he has 2 equally cost paths, tunnel 1 and tunnel 0. Okay. I mean, we could change that, but right now it's actually doing equal cost multipaths. But if I were to shut one down, I mean, then it'll only have one available option here. But that is how you set up MPLS traffic engineering. What other commands can I do? Show IP RSVP neighbor. This is our RSVP neighbors once we created our tunnels. That it has 2 neighbors going to router 1 and to router 2 because that is the actual path that it has. It should have a path to router 3, but right now it doesn't have a neighbor for some reason. Let me see real quick. Let me make sure that the config is correct. Yeah? Does router 3 have it? Show run interface S. You show run section router. Yeah, it has that on there. Why doesn't it have it? Well, I'm not exactly sure why it doesn't have a neighbor to router 3 right now, but it's definitely not using it. The tunnels that I have are going to router 1 and router 2 itself. But that's how you configure MPLS traffic engineering. You have to configure your underlying IGP. So in this case, I used OSPF. Then you got to enable LDP, your label distribution protocol. Then you have to define your RSVP path. So you have to go into all the interfaces to put in the IP RSVP commands and then enable MPLS traffic engineering tunnels globally and also on the interfaces. Then you go to your two endpoints, your PEs, and you create your tunnel interfaces. Okay? Define where it's going to go, and then if you're going to use a dynamic path or an explicit path, then you have to define your explicit path like I did here. Okay? Also make sure you announce it to your IGP so it knows where to go. So that was it. So I hope this didn't take too long, but this is how you configure MPLS traffic engineering. So I hope this was informative for you, and I'd like to thank you for viewing MPLS traffic engineering. All right, one more thing before I let you guys go. I needed to show you what path R5 is taking when it's trying to get to the loopback of R6. So I did the show IP route, and I showed you the MPLS traffic engineering tunnels, showing that it is up and it's working, but I actually didn't go through and do a trace route. So if I do a show IP route for 6666, we see that we have two equal cost paths, tunnel 0 and tunnel 1. And if I actually do a trace, 6666, source loopback 1, it is taking the path to 45.4, which is here, and then it's going up and then down and then to its destination right here. It's because it's doing equal cost paths. What happens if I shut down one of the tunnels? Like the path this is actually taking is actually tunnel 1. So what happens if I shut it down? Interface, tunnel 1, shut it down. Wait for that to go down. Let's do another trace. Look at that. Now it's taking 45, 45, 45.4, then 24.2, which is this path. So it's going straight across now. It's because the way that I had MPLS traffic engineering set up, there was two equal cost paths. Maybe there's other ways that I could tweak it, but I'm just showing you that my tunnels actually worked. So, all right, that's it. So I hope this was informative for you. I'd like to thank you for viewing.